Welcome to this explainer. Okay, today we're doing something wild. We are leaving the warm, sunny surface behind and diving headfirst into one of the absolute most mysterious, extreme environments on the entire planet. We're going straight down into the crushing darkness of the ocean's deepest layers. For decades, everyone just assumed these depths were completely barren, like a total wasteland. But as we're going to see, surviving down there isn't impossible. It's just a matter of some seriously remarkable, almost alien adaptation. So, the big question we've got to tackle today is this. What actually happens to life when you completely strip away the sunlight and then pile on literally 1,000 times the pressure of Earth's atmosphere? Well, to figure that out, we have to look at how nature aggressively rewrites its own rules to survive total darkness, freezing temperatures, and just bone-crushing weight. It's an incredible journey of extreme survival. Let's get into it. All right, let's look at the roadmap for our descent. We're starting way up top in the epipelagic zone. That's the warm, sunlit surface where tiny phytoplankton are powering the whole food chain. But as we drop in depth, the average temperatures absolutely plummet. We're talking a straight shot all the way down to near freezing oblivion in the Heddle zone. The moment we pass that 200-meter mark, we officially wave goodbye to the familiar, well-lit surface world. This invisible boundary, that is where photosynthesis just completely stops. We are now officially entering the dim, super mysterious mesopelagic zone, or as you probably know it, the twilight zone. As we hit this depth, the fading light completely flips the script. The warmer colors of sunlight, so your reds, oranges, and yellows, they vanish entirely. Why? Because those longer wavelengths are basically swallowed up by the water right away. Only the faint, much shorter blue wavelengths actually make it down this far. Because of this, the creatures here have to adapt. It's adapt or die, right? So they either grow these massive, oversized eyes to catch whatever tiny bit of light is left, or, and this is crazy, they evolve completely transparent bodies to basically turn invisible against the glowing blue shadows. No shadows, no predators. Now, since sunlight is so incredibly scarce, a lot of these animals just decide to make their own. It's called bioluminescence, basically biology doing chemistry to create light, and it's a massive survival tool down here. In fact, up to 80% of the animals in the twilight zone use it. Take lanternfish, for instance. They use it for something called counterlumination, where they match the exact brightness of the faint blue light coming from above to effectively erase their silhouettes. From below, they're invisible. But on the flip side, you have things like the anglerfish using bioluminescence as a glowing, deadly little lure to ambush whatever wanders by. Now, to survive down here, you've got to be ridiculously efficient. Look at how a standard single animal compares to something like a siphonophore. Instead of being one single creature, a siphonophore is actually a colony of thousands of genetically identical zoods. They all link up and function together as one giant ribbon-like body. And to handle the intense conditions, it totally ditches heavy muscles. Instead, it uses watery, jelly-like tissues. This is huge because it gives the colony neutral buoyancy. They can just float there and withstand pressure that's 80 times stronger than what we feel on land, without wasting a single drop of extra energy. Sinking even deeper now, down to 1,000 meters, and things get intense. The pressure hits 101 atmospheres. To put that into perspective, that is over 100 times stronger than the air pressure pushing on us right now at the surface. At this depth, we cross the invisible point of no return, straight into the bathypelagic, or midnight zone. So what you really need to understand here is how anatomy fundamentally has to change. Shallow water fish, they have heavy bones and air-filled swim bladders to help them float. If you brought one down here, it would be instantly crushed. Deep-sea creatures survive because of one simple rule of physics. Liquids don't compress, so they treat the bone in the air for low-density oils and these soft, flexible, incredibly watery tissues. Because of that, their bodies just effortlessly handle the immense stacking weight of the ocean, weight that would literally crumple a thick metal human submarine like a soda can. But, that adaptation isn't just large-scale physical stuff. It's happening on a microscopic level too, thanks to things called piezolites. These are tiny, highly specialized molecules hanging out inside the actual cells of deep-sea organisms. They work exactly like microscopic architectural support beams. They literally prop up the cell membranes and proteins to keep them from physically collapsing under the crushing void of the deep ocean. It's just mind-blowing biology. Okay, so with absolutely zero sunlight down in the midnight zone, plant life is totally impossible. So where on earth do they get their energy? Well, it drifts down from the surface as something called marine snow. It's basically a very slow, continuous shower of dead plankton, waste, and organic debris. Yum, right? But because the snow is so sparse, animals down here are forced into a completely different gear. They have to be incredibly patient, they move super slowly, and they conserve absolutely every ounce of energy they can muster. And since that falling food is just so insanely rare, these creatures have developed some absolutely extreme eating tactics. They simply cannot afford to miss a meal. Take the gulper eel. It can actually unhinge its massive jaws to 3 or 4 times the width of its own body. Or the black swallower. This guy can literally swallow prey that's twice its own length and 10 times its weight. Its stomach stretches so much it basically becomes transparent. Down here, the rule is you eat whatever you can fit in your mouth, period, no matter how ridiculously big it is. Which brings us to an absolutely brilliant hunting tactic. The stoplight loosejaw fish basically brings its own set of night vision goggles to the hunt. It shines a faint, completely private red beam of light from its face. Now remember earlier how we said red light doesn't penetrate the deep sea naturally? Because of that, most deep sea animals over millions of years completely lost the ability to even see the color red. So the loosejaw basically uses its red light as an invisible flashlight to perfectly illuminate and ambush its prey in the pitch black. They literally never see it coming. Deeper still, we hit one of the most wild biological mysteries in the ocean. Section 1. Deep Sea Gigantism. Let's look at why things get so bizarrely huge down here. The ultimate, most famous example of this is for sure the giant squid. It's amazing to trace how this thing went from literal sea monster myth to hard science. It started centuries ago with sailors telling crazy tales of 20-foot tentacles pulling ships down. Then, in the 19th century, scientist Japis Stream analyzed a massive, very real squid beak. Later, Moses Harvey gets his hands on actual netted remains, which led experts like Addison Emery-Verrill to build incredibly accurate 30-foot plaster models. Fast forward to today, and we have physical evidence suggesting these absolute units can stretch up to an unbelievable 60 feet long. Just wow. But gigantism doesn't just happen by accident. It's a direct result of this exact brutal environment. See, extreme food scarcity actually favors having a larger body because bigger animals can travel a lot further to find meals and they can store way more energy when they finally do eat. You combine that with near-freezing temperatures, which slows down their metabolism and makes them live way longer, plus an absence of fast predators and high-dissolved oxygen in the water, you get the perfect recipe for slow, patient, and absolutely massive growth. Moving on, we are plunging even further into the dark, between 4,000 and 6,000 meters down. The pressure violently spikes to 600 atmospheres. We've officially hit the abyssal plain. This is a freezing, almost completely silent expanse that covers roughly half of our entire planet's surface area. Half! And yet, we know almost nothing about it. Now, the flat, totally dark emptiness of the abyss is pretty much desolate, except that is when it's interrupted by a whale fall. When a dead whale sinks all the way to the bottom, it's like a massive biological jackpot hitting the seafloor. It kicks off this incredible, decades-long sequential ecosystem. First step, scavengers show up to strip the soft tissue. That takes a few months. Then worms and crustaceans settle into all that organic rich sediment. Finally, bacteria get to work breaking down the deeply stored bone lipids, releasing sulfides that sustain highly specialized microbes for years. One single dead whale can literally power an oasis of life in the desert of the abyss for decades. And finally, we reach the absolute ultimate extreme of our journey. Section 2, the Mariana Trench and the mysterious Haddle Zone. Even just mapping this trench was a monumental human achievement. It took some serious rapid technological evolution. I mean, early sailors were literally just blindly dropping heavy lead lines over the side of their boats. Decades later, the HMS Challenger is reeling out thousands and thousands of meters of physical cable. It wasn't until the 20th century that we finally figured out sonar, bouncing wide fans of sound echoes off the seafloor so we could finally see the massive trenches, ridges, and mountains hiding way down below the black water. At the absolute bottom of the Challenger Deep, we are plunging 11,000 meters into a gaping scar formed by shifting tectonic plates. The environment here tests the absolute breaking limits of physics and biology. The temperature is hovering just a fraction above freezing, and the pressure, try over 1,000 atmospheres. That is a physical force so unimaginably dense, so heavy, that it should just completely crush the structural integrity of any living cell as we know it. And yet, against all odds,
life persists even here. It's incredible. Scientists have found these tiny shrimp-like invertebrates down at the very bottom of the trench that, get this, literally produce a specialized aluminum-based gel. They basically wear this metallic gel like biological armor to strengthen their exoskeletons so they can survive the absolute most punishing, hostile environment on planet Earth. Nature finds a way, right?
Which brings us to our final takeaway today, and honestly, a pretty profound question. So far, only the tiniest fraction of this abyss has ever been observed directly by human eyes. If biological life can literally forge aluminum armor and adapt to endure the completely crushing pressure and eternal darkness of the Mariana Trench, what completely unfamiliar, impossible biology is just waiting down there for our submersibles and robots to discover next? It really makes you realize the greatest alien frontier isn't up in the stars. It's actually right here, hidden beneath the crashing waves. Thanks so much for joining me on this explainer. I really hope this sparked your curiosity about the deep.